Question 8 takes us to probability with this Venn diagram in which you're told there's a class of 21 students, 12 with a laptop, 10 a tablet, and 3 own neither. In part A, again, write down, should be fairly straightforward, write down the value of P. P is here, it is the number of students which do not have a laptop or a tablet, and we can see from here that that therefore is 3. Part 2, find the value of Q. Well, Q represents the number of students who have a laptop and a tablet. Now, we don't know what that is, so let's call it X. We do know that there are in total 12 students who own a laptop. So this would make our 12 minus however many there are in here, so 12 minus X, and this would make this S is the number who own a tablet, which is 10, so this would be 10 minus X. Now we know in total there are 21 students, so we also said P was 3, so 12 minus X, which is this region here, plus X, the intersection here, plus 10 minus X, this region here, plus 3, which is everything on the outside. We know that that equals 21, the total number of students, and we can solve that to get X equals 4, and of course here X is representing Q, so therefore Q equals 4. Part 3 then, again, write down the value of R and S. So R is going to be this, 12 minus X. We've just found that X is 4, so R is going to equal to 8. And similarly, S is going to be 10 minus X. We've just found that X is 4, so S is going to be 6. In part B, we're told a student is selected at random from the class, and we are asked to write down the probability that the student owns a laptop. So that will be anything in here, so that's just going to be R plus Q, which we said is going to give us 12. So 12 out of the total number of students, which is 21. So that's going to be the probability that the student owns a laptop. In part 2, then find the probability that the student owns a laptop or a tablet, but not both. So that would be just region R and region S. So we said that R was 8 and S was 6, so that's going to give us a total of 14 out of a total of 21. For part C, we are asked to copy and complete the following tree diagram, and you can see that previously we effectively worked out the probability that a student randomly selected had a laptop, so hopefully this agrees with your answer from the first part of this question. We can see that both of these add up to 1, so that makes sense as a check, and similarly in the second branch here for the second student, the two components add up to 20 as well. So this is what your tree diagram should look like in part C1. For C part 2, we're asked to write down the probability that the second student owns a laptop given that the first owns a laptop. So given that the first owns a laptop means we are coming down here, we are conditional probability. We want to find the probability that the second owns a laptop given we are in this branch. So the probability that the second student owns a laptop, therefore, is going to be 11 over 20. If you wanted to, you could express this, so probability that the second has a laptop given that the first has a laptop. Remember, if you use the formula, this would be the probability that the second and the first own a laptop given or divided by the probability that the first has a laptop. So if we did it like this, the probability of the second owning a laptop and the first is going to be 12 over 21 times 11 over 20, and we're going to divide that by the probability that the first student had a laptop, which is going to be 12 by 21. You can see that will cancel out and give us the same answer that we have here.